Hello, everyone, and welcome to another Friday evening. It is 7:30. Wow, excuse me. It is 7:30 p.m. Central Time here, and we are going to get right into doing something a little bit different today. That's right. I don't have a set of plans on my desk to look at today. Today, we're going to talk about some framing and roof geometry inside Chief Architect. And this goes for, of course, any houses that you're going to be using your roof geometry skills on, whether you're designing them in Revit or SketchUp, or you're just doodling it on paper, don't matter. So hopefully by the end of this video, you understand just a little bit more about a few little nuances. So let's get right into it here. I am inside Chief Architect here, and I've got some panels on the right that I'm going to get rid of. We don't need those. And I've got these two little buildings right here. Now, this is not my template. I have just opened up the raw Chief Architect template and made some stuff out of the, like, straight away. If you were to download Chief and start drawing, this is what your stuff would look like. So what do we got? Well, I made a rectangle that's a building, and then I gave it a porch, okay? So if we were to, I made two of these. Basically, the only difference between the two of these is this one has a brick facade outside the wall. So I'm going to bring up why that matters and like what there is to think about in terms of the detail for when that happens. But all you need to know is that's the only difference between these two buildings. So what's going on? Well, right now, all these lines right here, whether you can see them or not, these are roof planes, okay? And so everything is hip roofs. If I go to the outside of this building and we take a look from the outside, hip roof is when your wall, your roof plane, it just starts from the wall and it goes up at a specified pitch. If I were to grab this wall and say, you're not a hip wall, you're a gable wall. Now it creates a gable end like this. And you're used to seeing this kind of thing with houses in America anyway, because this is how we've built lots of stuff. So if I put it back to being hip, then that's what the roof does, and yada, yada, yada. So that is what the roof is doing for both of these, because that's just the way I set it up. Nothing special there. But we're going to talk a little bit about the front porch. And I've got this perspective framing overview up because I want to discuss what typically happens when you're framing a porch and how you can use proper alignment in your like your invisible walls or whatever lines you're drawing on the plan. All too frequently, I see people draw plans and they just don't quite understand where these porch lines need to land on the house. And most of the time, it's probably because they're not framers or they didn't understand framing in the past or they just like they didn't have the background. And that's, it is what it is. But for those of us that do understand, there is a preference for how this is all supposed to work. And so, what you ought to think about is how does this roof plane continue? Actually, if I'm going to do this, let's make this a little more visual. Oops. Yes, I do want to turn off auto rebuild. And then I'm going to delete this one for a second. So if I go to the framing overview, I want to, oops, it's not going to do it for me. I got to rebuild all the framing. Okay. So all these rafters right in here that are originally, they're on the wall of the house, right? But as soon as we stop the house, the wall ends. And so you have to ask yourself, well, how does the roof plane like this continue to extend without anything to sit on? And so that's where you think, oh, we should put a beam in there. All right. And that is exactly what we do. We go over here to our plan and we said, hey, okay, I'm going to grab the ceiling beam tool that I've got. I'm going to drag one out. And then you ask yourself, well, where do I put it exactly? Here's what you do. In most cases, you take the outside of the beam and you snap it to the outside of framing. And what that does, and now the inside width, it could be like 3 inches because it's 2 plies, a 2x12 or whatever. Or you could make it the full thickness of the wall and then like fur it out with blocking. You could do all kinds of stuff on the inside. But typically, you want the outside of that beam to be right in line with the outside of your framing exactly. And what's going to happen is, well, how tall do I make my beam? Where does it go? That's a great question. Basically, what you want to do is you are trying to cut your wall such that Let me turn my rafters on. Let's show those. That'll be a good thing to see in here. Framing. Ooh boy. Roof rafters. Okay. So basically the rafter has this bird's mouth cut and it sits right on top of the wall. So what you want to do is you want to keep that geometry the same. And so the top of beam is always going to be at top of plate, assuming you're trying to continue the roof plane just like there was a wall there. So if we got rid of this elevation, we would see that this beam, if we opened up the settings of this room and said, hey, what's the structure? The ceiling is framed up to 109 and 1/8. Why is it 109 and 1/8? Well, it's because it's a 9-foot ceiling, which is 108 inches, and you add an inch and an eighth to the wall height because you're using pre-cut studs, and it's that way because it makes it easy to sheetrock. So that's the number. If you're trying to do the sheetrock pre-cut stud method, you're going to add an inch and 1/8 to your walls. So that's pretty standard. But you'll notice that is the rough ceiling height. That's what it's framed to, 109 and 1/8. Now, if I go click on my beam and open it up, it says, hey, what is the top of my beam? Well, it's a 12-inch deep beam, but the top of the beam is at 109 and 1/8. Look at that. So what's going to happen is if I slice the wall at the beam and take a look at it with a section view, I'm going to see that, hey, look, the beam, now ignore the blue because the blue is siding, which is outside the wall. The beam is right exactly, excuse me, it's right exactly where my wall was. And so the rafters basically don't care if they're sitting on a beam or the wall, they're cut the same way. And so knowing that, when you're doing porches, you want to pay attention to how this ties in, and you want to rely on existing wall geometry. Now, if we, for example, had the porch like super narrow and it was way over here, then we wouldn't really care where we land it because it's going to land in the wall wherever. But that is not the case. So that is what we deal with when we're talking about beams and coming off of a wall here. So slight deviation, what happens over here on this house when, because like people when they're drawing these, typically they'll draw lines that represent the beams for the roof, or at least the edge of where the roof geometry happens, which is what the framers need to know. But the foundation guy might need to know something else. Now, in this case, it's the same. The edge of the porch to the edge of the outside of framing, when in this case it's 11 foot 8.5, the framers are going to frame to that number, and the slab guy is going to put the slab to that number because there's no brick going on here. Everything's in line. But over here on this house, if we go to the overview and we take a look at what this guy's doing, you will notice that here's the beam thing going on up here, and the brick lug needs a lug, right? It needs to sit on something. So the framing is in line, but the slab sticks out where the brick is because the brick sits outside the framing. And so what most people do, or at least what I do in most cases that makes this all look nice and clean, is I say, oh, okay, there's just my slab, I'm just gonna extend my slab. And so when I draw this in my software and my plans, I would just take a line and I'd run it out and I'd put a solid line showing the edge of the slab. Now, when I'm dimensioning my plan, I'm not gonna dimension to that line. I'm gonna dimension to my framing because the floor plan is mostly for the framers. So the framers need to know, hey, my roof geometry, all my framing is based on my wood. It's not based on my slab. And then I'll be very careful when I go and dimension my slab plan. I'll say, hey, the slab is bigger. Watch out for this, And for me to control the computer, if you're someone who uses Chief and you want to know how to do this a fast and easy way, what you're going to do is you're going to use the invisible wall right here, which is the representation of the beam. Wall's invisible. And you can actually open it up. And in the settings of wall types, you go define it. You can find in the wall properties, there's a section here for foundation offset. So if you specify -5.5, although I think in the computer it's defaults 4.5 for whatever reason, we'll just hit OK. It's going to automatically push the slab out, assuming the foundation rebuild is on. automatically. Yes. Yep, that's fine. There we go. Look at that. Now, in the for whatever reason, Chief thinks that brick lugs are 4.5 inches default, and it's a little bit silly for that. And so I've had to fix all this in my templates and all that stuff, which you can download on my website if you want. There's a link in the description for all those things. But yeah, you're going to use the computer to say, hey, push the slab out just a little bit farther, leave the framing where it is, push the slab out, and then this is how you're going to get it. And then at the bottom of the post, you're just going to have more concrete outside the post, and no one's going to be offended by that. So that is the easiest way to do this and make this look the best. There are other ways to basically adjust the post and adjust the framing, but then you start to get into more difficult rafter framing, because now if you move the post or move the beam, you have to cut the bird's mouth differently for the rafters that are on the porch. And that doesn't, no, we just don't want to do that. We like to use all of our nice easy numbers. So like the guy who's cutting out all the rafters for, let's go to my framing overview, 3D perspective framing. So if I go to this porch, right? So the guy that's cutting, we're going down this hip. The guy that's using his math to calculate the length for each one of these rafters is going to have to change his math, because if this beam's not in line with the wall, see how because they're in line, the rafter math stays the same. So anyway, that's just a thing that happens that you want to do and you want to pay attention to. And yeah, that's how that works. So the other thing I wanted to talk about, and I'm going to check the chat real quick, make sure I'm not missing any important, wonderful, valuable chats. Looks like it's fairly good to go. So let's hop right back in here. The other thing I'm going to talk about that a lot of people kind of get confused about, that I see, man, I've seen some weird stuff in people's plans sometimes. And you're just like, okay, they don't know what roof planes do. Okay, let's talk about roof planes. So do that. I'm gonna grab all these, delete them all. Grab all these, delete them all. Grab all those, delete them all. Okay, this is why I have all these buttons on my mouse that allows me to do all these commands without touching any buttons. It's very nice, very fast. Okay, so we need the roof to be auto rebuilding. So let's turn that back on. And then let's build a house again. Okay, let's take the regular exterior wall, and we're going to start with a really simple rectangular house. Oops, too far. Okay, so it gives us this hip roof. This is hard to see, so I'm going to tell it to not be green. Tell it to be black. And also be solid. There we go. That's a little bit easier to see. Where's my grid? I want the grid off. Oh man, I'm not going to waste your time. Okay, so here's my roof planes. And what people often don't quite understand is what happens when you've blended. There's got to be roof labels. Okay, so it's showing the pitch here, 812 going down. So everything's an 812. If you modify your pitches and you make the same house design with multiple pitches, because frequently people will like, hey, my view from the front, my elevation looks kind of like okay like this, but I want my house to look a little bit like steeper, grander, taller. And so what they might do is they might take these side roof planes and open them up and say, I don't want an 812, I want a 1212 on the sides. And so you say, okay, yeah, turn auto rebuild off, whatever. Now, if I left this alone, all I did was change the pitch. And from here, it looks like it's correct. But if I go to my outside view, you're going to see that it's very much not correct. This is not how the house will be built. And so what you're going to do is you're going to use the join roof planes command, and you're going to rejoin all these edges to each other. Oops, come on. There we go. And then it's going to be corrected. All right, so there we go. That's good. If we go to our elevation view, look at that. Now the house looks a little steeper on the side. It's just going to look a little grander, right? And so that's frequently a strategy people like to do. But what they forget about is what happens out here on the eaves. We have a 1'6" overhang. Come on. Yeah, 1'6" overhang for both sides. But for whatever reason, this is not lining up. Why is that the case? Well, let's go look. All right. So what happens is because you now no longer have two even roof pitches coming together, you have this jut out thing. And you have this because if you were to look at, let me grab all the roof planes and make, oops, that's open. All right, we're going to box all the eaves so they're flat. Makes it easier to see. And then we're going to slice this at the wall and take a look. Okay, so this is your soffit as the roof is steep, right? So if I go out 16 inches and I have a steep roof, my soffit's going to drop down much lower than if I cut this way. Oops, that's at an angle. That's going to be confusing. If I cut the wall that's shallower, right, my soffit is going to be less steep. Let me just pull a number here so you have a number. So from the soffit material to the top of the wall, looks like it's 1'3" and a half. And if I go to this one and I pull a dimension from the soffit to the wall, it's 1'3" and 3/16. Why is it the same? That's not right. Hold on. What is going on here? Oh, that's why. I put the wrong dimension. Okay, this back here is the other soffit from the steep roof. This is my soffit from the shallow roof. My bad. 9 and 9/16. Okay, so 9.5 inches is like the difference between the soffit material and the top of the wall for the lower pitch with the same 16-inch overhang. Okay, 16-inch overhang on a steeper pitch gives you a deeper soffit. So what happens when you try to resolve those geometries together in a corner is you get this. One of these things is going to go down farther than the other. So how do you fix this? Well, most of the time, people are going to prioritize the steeper roof pitch, and they're going to modify the overhang size of the lower roof pitch. All right, so I'm just going to take the overhang of the lower roof pitch, and I'm going to snap it out to here. And I'll do that on both sides. I'll bring it out. Okay, so now I have my regular 1'6" overhang on my steep pitch. But if I go measure this side, now it's 2'2" and 13 something something. Okay, so that's the one that's modified. Now, most of the time, you'd probably pull this into like a 12-inch overhang because it's so steep. You don't want to cover your windows and stuff. And then you could pull this back, and now this is not going to be such a big, fat 2-foot overhang. This is going to be more realistic, 1'6", basically. Okay. So that would be the appropriate way to handle this. But every time you change the pitches, this is going to have to be readjusted. So pay attention to that because these are not the same. You cannot have equal plate heights, equal plate heights, unequal roof pitches, and unequal overhangs. So there's like 3 factors, okay? There's overhang distance, plate height, and roof pitch. Those 3 things will determine how corners come together like this and how soffits are built. Now, is there a way we could have 2 uneven roof pitches and even overhangs? We could. Watch this. If I make this one 12 inches and this guy is 12 inches, okay, so now I have the same overhang, different roof pitches. If I go look at this back corner from the outside, it's not going to look good. Hold on. Let me go find it. Don't save. Don't save. Okay, so I'm going to go look at this back left corner over here. So we have this problem right here. Okay, so that's the problem we got. Now, how could I possibly fix this? There's another way while keeping the overhangs the same, and it has to do with adjusting the plate height of the roof. Okay, so you could actually frame one of these walls taller or shorter, and it will resolve this. So how does that work? Well, let's basically try adjusting one. Let's take the back roof plane. I'm going to go to transform replicate, and I'm going to push it up in the Z direction. I don't know, 2 inches. Let's see what happens. Okay, I'm going to make it go up in the Z direction, 2 inches. Now, I'm going to rejoin the roof planes because now they're different. All right. And then I'm going to probably move it up more than that. Actually, I need to go the other direction. I made it worse. I need to go down. Let's call it minus 6 inches. So we are total net. We're down 4. So rejoin them. Aha, that was pretty close. Okay, see, it's a little bit off. In a perfect geometry world, that would not line up. And so like you could adjust the math to figure out what the number would be. But what happens is also ugly framing, because now your hip is not landing right out of the corner. So this is something I don't recommend really ever doing unless you absolutely need to, because it makes the roof geometry a total bitch. So don't recommend it, but like this is what it looks like, okay? So you have uneven roof pitches, you have even overhangs, but you've sacrificed the plate height being the same. So if I were to frame, let's look at it this way. If I were to section this and look at the wall height, how can I do this easily? Oh, I'm looking at the right one. Right? No, I dropped it down, I think. Yeah, I dropped it down. Okay, so here's the problem. Is because I took these rafters and roof plane and I pushed it down. Remember, I went negative 4 inches. Now, if all my flat ceilings were 9 feet, I have this little chunk of rafter that's like now part of my room because I pushed the roof plane down into the room. So you could get around that by lowering the ceiling height in your room, like furring it down or something, or all kinds of other things you could do. But it's just not a good idea. That's not a good thing to prioritize. Most of the time, it's a lot easier just to change the overhang size. Everyone's happy. The hip or valley will land right off of the corner of the wall framing geometry, which just makes everyone's life easier. And then, yeah, now it's like you don't have a whole bunch of unhappy drywallers and unhappy framers. And yeah, it makes everything hunky-dory. So, excuse me, recovering a little bit from that Rona, I think. But yeah, that is what we talked about. So what are the 3 factors? Overhang of the roof, pitch of each roof coming together, and wall plate height, or baseline height, if you want to refer to it as that. Every roof, when you start it on the wall, is based on the outside of framing when you're talking about geometry. And so what you're doing is you're basing it on a particular height and geometric location in XY on the plan. And so in this case, this roof plane used to be in a normal spot, but then we moved it in the Z direction down 4 inches and we got this problem. Now, if I put this back, bring it back up 4 inches, and then I rejoin the planes, it brings this right out to the corner and everybody's happy. So of course, if you change your pitches back, it would be 45 and all that stuff. So yeah, that's our little bit of a lesson today. Let's look at the, actually, let's undo that and look at the framing. So you guys can like really, really wrap your heads around how annoying this would be. And we got to build all framing, and this the settings in here. Okay, this is the back. Okay, just take a look at how like nice this is here. So the computer didn't even quite understand what to do, because it was like, hey, wait, do we need like 2 hip valleys? And they're not like here on the corner of the house, they're offset. Just imagine like having to make these cuts and put all this together. It would not be pretty. What's going on here? Oh, I need to drop the roof plane. Let's fix that. I undid too far. Let me go back. Oh, it's going to do that. Okay, hold on. We're going to go Z minus 4. And then we're going to build all the framing again. Yep. Oh, I guess it's showing it, whatever. Now we go back. There we go. Okay, so now it's 1 hip. And this is what it does. So like the wall framing drops. It's just nasty. It's just nasty. You just don't want to do this. Don't do this. All right. That's what I got for you guys. Hopefully this has been a helpful, slightly different Frame It Friday. And I will see you guys on the next one. I do have the Scrutinizing Sundays coming up, Sunday, 10 a.m. Central. I have a lot of stuff to cover in terms of what I've been learning about growing this design business and cool design building stuff I learned along the way. I talk to a lot of builders and I pick up on a lot of little nuances that they all kind of give information for here and there. And I'm down to share it all with you guys. So join me tomorrow, 10 a.m. Central. And that is what we got. So, looks like we got Mr. Eugene. Hello, Mr. Eugene. Well, happy early Merry Christmas. Happy early Merry Christmas to you, Mr. Eugene. Good to have you on the channel. Hopefully this has been helpful. Good to have your support, and thank you for coming on here. And looking forward to helping teaching more as I come up with more stuff. We'll see you guys on the next one. Let's take it out with some music by you know who, the one and only Green Observer.
That's the code.
And hold that thought. Almost missed a comment here. Okay, let me check my sound, make sure I'm still good. Sound check. Yeah, okay. Mr. Eugene had a question I would like addressed because we don't want to miss questions. Okay, in what situations you use LVLs for hips and valleys? What a great question. And the answer to that is when you need a hip or valley to be a load-bearing beam, you would bump it up to something that can bear more load. So what's a load-bearing thing? Well, in most houses, so when I'm analyzing most framing top-down like this, right, we're talking about all the bracing that we put on the hips and valleys and ridges and stuff like that. You need LVL as a hip or valley member when you can't brace it up. Okay, so you need to think about this. Your ridges, your like this ridge board up here. It's technically it's gonna be used as a small beam because you're putting braces on the ridge every 4 feet. Technically, you have little 4-foot beams holding all your rafters. That's the way to look at it. So when do you use an LVL? Well, it's when your bracing gets too far apart and you can't brace, or you don't have the room, or like there's nothing to support it on. That's when you use LVLs. So frequently it's going to happen in like low slope areas where you can't fit beams in the ceiling area, and you just have to get a hip from like one corner of the wall, like 14, 16 feet into the house. Something like that. And there's literally nothing you can do to hold the weight of the hip. Actually, you know what? Here, let me give you a common circumstance. Let's delete all these and all these and all these. Oh man, this is messy. Okay. Delete this, delete this. Okay, let me give you a brief example. If I've got an exterior wall like this, and I make a house, and then I divide it up with some interior walls like this, and I have like a master bedroom in this corner. Something like this is common in a master bedroom because like people do this thing sometimes. Excuse me. If I ever build where okay, so let's take a look at this. The roof is 9-foot plate. Okay, so my walls go to 9 feet. Let's build the roof. Let's say that's like, hey, we're going to use a 612. That's very common. Okay, and I actually want to auto rebuild all the roof. Okay, so if I build the roof like this, and it's a 612, and then I go look at the framing, which is here. I don't normally use the framing view. Oh, geez. This is why I change all the settings in my templates. Okay, so take a look here what we got. All right, this is fine. So we are inside the attic and we're looking down at the master bedroom. This hip over the master bedroom has to basically cross the master bedroom. Now, as it is right, excuse me, as it is right now, I could very easily take a beam and run it across the master bedroom like this. And nope, I need you to be hidden. So bottom of the beam is 109 and 1/8 because this is up in the ceiling. And let's make this like a different color so we can see it. Let's make it a nice dark birch medium or something here. Okay, so there's your beam. Okay, so I could easily put this beam in here. You can see how easy this fits in here. I set it on one wall, I set it on the outside wall, and now I can put roof bracing on the beam. I can put as many of these as I could put as many as I need across the ceiling because this is the current design scenario. If I deviate from this and I do this special thing where I don't want to see this on this plan. Hold on. There we go. Now I can see what I'm doing. All right, so if I take this room and I say it's a master bedroom, I would like it to be more grand. I'm going to bump up my ceiling to a 10-foot, which is 121 and 1/8. And undo that because I want my roof to stay alone, to not move. Let's do it by just modifying something here. Okay. So auto rebuild is off. My roof will be left alone. Okay, so I'm going to take my structure of my ceiling and I'm going to say 121 and 1/8. Now, look what popped up. This dashed line and this dashed line. Why are these here? Those are there because now it's representing what happens to your ceiling height inside your bedroom. Okay, we pushed the ceiling up to 10 feet, but the walls were only 9 feet tall. And this is very common, excuse me, in spec homes where you're trying to save money and you want to give some grand space to a room, but you don't really want to build the 10-foot wall on the outside of the house. It costs more money. So you do this. Now, this is all fine and dandy, but as you can see, we can't put the beam here anymore because it would stick out. Unless you wanted a cool feature where you got a beam sticking out, you have to pick the beam up. So, okay, fine. We're going to transform replicate this beam up 12 inches and we're going to put it back above the ceiling. So now, cool, we picked the beam up above the ceiling, it's gone, everybody's happy. But wait, there's more. If I go back to my framing and I look at this, okay, looks like this wall, is it supposed to, there we go. Okay, so it's supposed to build the wall taller. So now my wall's taller, okay? So I got a 10-foot wall on this side. Everything's cool there. And my ceiling joists are stopping and splicing on my beam. That's fine. But take a look at this side. What is the problem here? You see what's going on? Now my beam's too high and my roof, like this wall didn't change because this is a 9-foot wall. So unless you're willing to do some ridiculous, crazy engineering detail to make this joint stiff enough to hold this weight of the beam, you cannot put a beam, you can't run a beam into a sloped ceiling end like this. Now, the reason it works with all the ceiling joists like this, like, you know, this is typical. This works because each ceiling joist is light enough, it's not putting a bunch of load on each rafter. So it's not a big deal. But when you have a situation like this in the corner of a room, and you've done this to both sides, I can't put a beam either direction, right? Because if I run it the other direction, I have the same problem. So we don't see it in this view, but if I go this way, I have the same issue because I can't put it on the wall. And if I can't run a beam across, then the only thing that I could possibly do is like turn the beam at an angle and try to like cross the room like this, which would just be like stupid and weird. Like I could do that and now I can brace the hip over here, but most people are going to be like, I don't really want to make a 45-degree beam. That's kind of weird. And so they're just going to they're just going to not put a beam in. And they're going to rely on they're like whatever brace they can get. And let's actually figure that real quick here. If I look at this at a 45, what I'm looking at, ooh, this is kind of confusing. Oh, where am I? This is dizzying. Hold on. Oh, let's move it closer. Let's put it right next to it. Okay, perfect. So this is the room. Okay, here, over here on the left is where the room stops. That's where the walls are. And then this is my hip going up at its angle. So what I can do is I can use a line and I could go up at a 45-degree angle and I can brace. This is not that easy to see. Oh, you're going to just have to imagine it. So I could go up at a 45-degree angle with a brace and basically like, get in the room a little bit and brace out at an angle to the corner. That is the best I could do. But frequently what happens is that unbraced distance over here, look at that, that's 19 feet horizontally. Okay, so look at the plan. If I can brace here to my wall, that's great. But I've got this whole unsupported hip, which is 20 feet long. See that? So this is a situation where if I was engineering this, I would say, like unless you're willing to do a weird 45-degree beam thing and like get closer to supporting this, or do a special detail on the edges, or like, I mean, there's always infinite number of ways to solve the problem. You could also put one brace down, like if you really wanted to avoid putting a funky hip, expensive LVL hip here, you could brace down to each ceiling joist and basically say like, all right, fine, each ceiling joist is going to be a 2x12, and I'm going to put a little bit of weight on each ceiling joist. And now it's like you've basically spread the load out over a whole bunch of different items. And like, yeah, that's probably cool. And as an engineer, that would probably work out just fine. So this is where that happens. Let's take a look back inside the framing. So it's when you have a situation like this where you can't put a beam supported on either wall of an outside room because of the weird ceiling raise, and you just have a really long spanning hip. Because like, what is this hip? The hip is a beam. It's just going up at an angle, and it's carrying all the weight of all these rafters that are sitting on it. So I hope that answers your question. Hope that was useful. All right, let's take it out again. Great question from Mr. Eugene. And now we are going to end it for the evening. Thank you guys for coming in. Let's take it out again.
That's the code.